Hi and a very good day. So in this video session, I will continue discussing on one topic under univariate modeling, which is Holts method. Right? So this Holts method actually also belongs to exponential smoothing group, where we say that the exponential smoothing method weight the observed time series unequally. Okay, more recent observation weighted more heavily than more remote observation. Okay, so this weighting actually can be determined by the smoothing parameter that we choose. Okay, whether one or more smoothing parameters. So the difference between Holt's method and our previous exponential method is now this Holt's method we will need two parameters. Okay, so let's take a look at the equation. Okay, so this is basically the equation for Holt's method. Okay, the idea why we choose the Holt's method, okay, the thing is, suppose that we see our observation display a linear trend, whether it will be increased or decreasing at approximately a fixed rate. Okay, so instead of we consider to do the smooth at our series level, we also need to consider to smooth the trend component. Okay, so that's why we will have, okay, this first equation as t, okay, to smooth the level, and then this tt, okay, this is for our smooth trend, to estimate the trend component, and okay, to forecast the multi-step ahead forecast, this is equation that we need. Okay, ft plus m equals to st plus tt times m. Alright, so here, as we can see here, you will have two smoothing parameter, which is alpha and beta. One smoothing parameter to smooth the level, to give the weightage on our level, okay, and then the beta, this is the smooth parameter for the trend. Okay, and okay, so let's take a look at on how to fit the Holt's method using Excel. Okay, the thing is, the most important part when you want to model exponential smoothing is to determine the best value for your smoothing parameter. Okay, so instead of one, now you need two parameters, so you have to determine the best value of alpha and beta. Okay, this is actually can be done in with two approaches. Okay, the first approaches, okay, the forecaster, we by our own self determine the best value of alpha and beta based on the data characteristic. Okay, and then the second approach, you can let the series determine the best value of alpha and beta. This is actually can be done when you use solver, right, like my previous example. Okay, it also can be done. Alright, so before we begin, let's say that we fit the Holt's method by using alpha equals to 0.6 and beta equals to 0.2. Okay, so here let's take a look at our our data set. We will use the same data set now to estimate the Holt's method. We will need, okay, st and tt, and also y hat. Okay, y hat here is the value that we produce based on, okay, st plus tt times 1. Okay, for estimated process we will use m equals to 1, right? Okay, the error, the actual minus fitted, and error square, this is for calculating the MSE. Alright, okay, so the alpha here, as we can see, alpha is 0.6 and beta is 0.2. Okay, so here okay, you need an initial value to start modeling Holts method, right? So the initial value for ST is equals to the actual value at T equals to 1, so 331.3, and also the Y hat also, okay, we also use the same value as our first observation. While for TT, since that we cannot observe yet, okay, the trend or the growth rate, so we let the TT equals to 0. Okay, now we will start putting equation in this cell, okay, ST. Okay, you can refer to this equation, okay, ST equals to alpha YT plus 1 minus alpha ST minus 1 plus TT minus 1. So how do we do it? Okay, so here instead of I put the value, it actually can be done, okay, if you want to just simply put the value 0.6 times and so on, but for the purpose of demonstration I will refer to these specific cells and then I lock this cell so that when we drag the value, this cell will not be changing. Okay, so now, right, okay, times, okay, alpha times YT. So YT here is the same as our TT. T equals to 2, so Y, okay, Y2, okay, plus, okay, 1 minus, okay, alpha, okay, times, okay, time ST minus 1 plus TT minus 1. So ST, okay, it is best for us to put parentheses here, okay, ST minus 1 plus TT minus 1. This is the thing, you have to make sure that you select the correct cells, okay. So ST minus 1, so S1 plus T1, okay, because we start at T equals to 2. Okay, so we enter. Okay, so TT, right, beta. So here beta, I lock the cell. Okay, times, okay, ST. So ST here is our current period, ST, S2, okay, minus, okay, the previous period, ST previous period, okay, plus 1 minus beta, right, 1 minus beta, okay, 1 minus beta times, okay, T minus 1, the previous trend component, estimate the estimate value for TT. Okay, so the previous estimate value, and then you enter, right? Okay, now our Y hat, okay, so this is Y hat 2, so it is actually, okay, S1 plus T1 times 1, okay, for estimated process. Okay, this is just for your illustration so that you understand. We use this particular formula, okay, instead of F, now we estimate, so Y hat, okay, F Y hat 2 equals to, okay, S1 plus T1 times 1. Okay, that's the thing when we estimate the Y hat, right? Okay, so now you enter. Okay, so the thing is, you just drag and then you drag, okay, and then you drag, also drag, okay. Okay, so error here, okay, actual, okay, this is actual value minus fitted, then enter, right, drag, and then the error square, okay, drag. Okay, so to calculate the MSE, the MSE is actually, okay, the sum of, okay, the sum of our error square here, okay, over how many observation, okay, 38, so over 38, right? So this is our MSE. Okay, so now, okay, this is what we fit our model, okay, by using Holts method. And suppose that, okay, you want to forecast, okay, one step ahead, 1 year ahead. Okay, so this is our forecast. Okay, okay, the idea of forecasting is we does not have the actual value yet. Okay, so let's imagine that we does not have our 1998 actual value yet, 1999 and 2000. So you want to forecast, okay, this is m equals to 1, this is m equals to 2, and this is m equals to 3. Okay, so the so the formula is equals to, okay, equals to, right? Okay, we, okay, I prefer, okay, refer to y hat here. Okay, equals to, right, st, okay, st plus, okay, tt, okay, this is times 1. Okay, this is your forecast value. And for this, okay, it is actually tt plus st times, okay, 2, right? So this is your value for 2 step ahead, while to, okay, st plus tt times 3 for 3 step ahead. Okay, so this is your forecast value, right? So that's the thing for Holts method. Okay, you can change the value. Okay, okay, so we say that lower the MSE, okay, it is actually the best smoothing parameter. Okay, so I think that's all for this video session. Okay, you can try by yourself, okay, whether you get this value or not. Alright, so you can comment, you can reply, and if you don't have, if you have any question, you can comment. Okay, and I think that's all. Thank you for listening. Bye.